Hi guys, apologies for the microphone for one. Unfortunately, I am in the middle of a load of different things with regards to life. So unfortunately, my microphone stuff is elsewhere and I am having to deal with a load of different environments, which means recording videos and doing stuff is much harder, but I'm absolutely fully for it. So I have to just crack on with it. Config extraction, that's what we're going to be talking about today. Really important subject, something that I want to talk about and I've wanted to talk about for quite a while. So this is definitely not YARLs. A lot of people say, oh yeah, it's getting a pattern and identifying it. First, we want to be able to identify samples. The reason for doing this first is we want to make sure that we got the right variant and we want to get the right malware, because we might have malware configs that are de-obfuscated or decoded in certain ways which we've missed that we need to identify, and sometimes they might be different malware but they're very similar. So we absolutely want to identify the right samples before we extract configs. We don't want to do it willy-nilly and try and extract out of just all of the samples that we have and hope that we get just blind ones, because that's just going to be ineffective. The whole reason for extracting configs are a number of reasons. One, for more indicators of compromise. Sometimes we have mutex values before we even begin to reverse engineer. We can understand mutex values, registry keys and stuff like that. Sometimes we get something that will help us for more research purposes or understanding of the group, threat actor, malware operator, whatever you call it. Such as like campaign ID, builds, comment, stuff like that. It's really important sometimes to understand what the person is thinking, or the people are thinking, the group. So the assumption is we collected correctly some samples, and a real important one is correctly, because we want to make sure they're all to a certain degree the same variant. We don't want to have things like NJRET and Emotet together. This is definitely not a definitive guide. This is definitely just a walkthrough. I want to put that out there right now. Understanding the assembly. So we want to be able to get small portions of the executable, identify it as being the config extraction or the config de-obfuscation. I want to focus on that and try and understand that very fundamentally to be able to replicate that in C or Python or whatever you want. So really, really important we do that. Just want to put here for a footnote that I absolutely am going to be doing Ghidra videos. I've been looking in Ghidra at work and really enjoying it at the moment, but before I release videos on Ghidra, I want to make sure that I get a solid understanding of it, the features that I enjoy, of course, the decompiler, but I just want to get something material before I put it out there and put it into a video for you guys. So, yeah, this is a sample from a malware variant that I'm absolutely not going to talk about. What's really interesting here is this is really inefficient. So a lot of people that understand assembly are going to be disgusted at this, especially with people in the C++ realm. They will probably be disgusted at the optimizations in this. So I apologize, but this is from a small segment. As I say, you need to understand a small amount of code. You need to identify where it is. It's usually find resource. That's all I'm saying. But sometimes it's a little bit harder than that. So I've given the game away already with that. But we're going to go step by step for people that don't fully understand or enjoy me doing step by step on videos. That's what I get a lot of feedback from. So that's what I'm going to be doing. So yeah, first of all, obviously, return. I say success, but it just returns the value 1, which is going to be success. Really important here, seeing the EXOR EAX and then seeing here EAX. A lot of changes. Very important to see the changes. And some people will be like, well, it's all doing stuff, and then it returns it. So that must all be the success value. Absolutely not. If you're new to assembly code, you absolutely have to watch out for stuff like that, especially when it's malware, for one. So location increased by one statically, not by register. So what I mean by that is it doesn't have an index and a scale. So in your assembly instructions books, or your, well, no one's reading the Intel book, but the assembly secrets or malware analysis for beginners, whatever you're reading, you'll probably see some point someone talking about the EAX, the index, and then a scale, or like a value, an address, index and value, and scale. And the reason for that is it helps you iterate through memory and D-word, go through as D-words or something like that, right? In this case, we do not do that. So we are doing it in a D-word in 4 bytes. So we see 80, 81, 82, 83. So that's 4 bytes. So we are working with 4 bytes. And we also see the add EAX4, which we'll move on to a little bit later. But we can see that this is very clearly something to do with 4 bytes, and plot twist is the value that we start off with that we move to transform and put into a result. So the EAX index, so we can see in the EAX being highlighted consistently here that that's the index. We also see it here adding, so we've got the static values set here, 80, 81, 82, 83. So we've got a block of 4, and they are being set from a precise location. So they are all the same, EAX, EAX, until we reach here. And then the loop goes back up, and then they're all the same but added +1. So that's real important. Or sorry, +4. Oof. It's real suboptimal, shouldn't be done like that, but it is. We are then moving that into ECX, which is fantastic. It is then XORed, as we can see here. It's the same value every time, which makes it very simple. It's just introduced again and again. You can start to see a repetition in all of the lines once you start to stare at it long enough. So we see the ECX value that we get here. We get a value from this byte, and we store it into EDX. And the DL, which is the 16th bit, this is a 32-bit. Half of this, the lower part, because we've got the L, DL is put into this location, which is the 80, which we've been referenced here. So it replaces that. So quite intricate in some regards, but once you've talked about it a couple of times, as I have, you start to notice it's simplistic. It just takes a few minutes to get used to. It's assembly. And then you've of course got the transform operation. You've got the 0A5, and we can denote that H is for hexadecimal, of course, in IDA. And we've got the length of this, so if you're wondering if you extract it in most config extractions, if you're extracting out and you get a different length from what's getting compared, definitely have a look at that and be like, maybe I've got the wrong amount. It's also good to see the sometimes in hex editors you see in the ASCII a dot, but it's something ridiculous like 01 or 02 or 0A or whatever. So yeah, definitely have a look at that. It's not that hard to replicate outside of IDA. As we can see here, these are actually static values being set here, all of them. So actually in the data segment, as we can see from DS, so there's not actually too much to worry about. There's no memory locations, so in regards to the initial ones. So we're pretty happy that we can actually do this outside of IDA and replicate it for C++ or Python. So of course, I went for the easy one and went to Python. So first of all, we need to make sure we have a while loop that starts with 248. If you haven't noticed, 0F8. I really hope that's 248, or I've been doing it wrong and I've just said to people that that's right. Anyway, so we need a while loop. This is a loop. We can see that from the looping nature, and it's green. So jump less than. So we've got that under control. We've also got the index, which is set as 0. Really, I have done it in the same way as the assembly, which hurts, but you know, needs must. Index equals 0 is essentially this exclusive OR that clears EX by itself, or on itself rather, and then we're setting the index, so we have it go one by one. So we've got the increment here, 1, 2, 3. So I'm replicating it by going through a few lines. So yes, and we can see for A in range 4. This absolutely could have been optimized, but hey, what can you say? Of course, remember me talking about the index and scale. So here I've got the I and the index. So we've got hex pool, which will be what we'll be grabbing from here later on. So we need the I, the value, to be incremented at a certain location. So that is the EAX as well as the index. So good to highlight that. We've also got the exclusive OR ECX with the value 165 is the value. Wondering why I'm casting is because I've always had problems in Python with some of the data types. So integer always seems to be good for me. So once we've got the final results, so we're casting this into an integer hex, XORing it, and also looking at it into a certain pool that we'll get. So basically, you should grab this and this location when looking at config extraction. So there's 2 places that we should be grabbing to get this. So there's an array that later on I will be showing you most likely, where we get from the pool a value index that we get from here, and this is then appended into a result, and then we go through the operations in the while and the for until we'll print it out. So beautiful. And of course the appending, as I say, the hexadecimal version, of course, recasted into a list. So other bits, stuff that's less interesting, but yeah, I need to say, so in this case in Python, basically I was listing a directory, making sure it started with exe, and was saying, yeah, we need to look at that thing, open it up, read it, read bytes, very important, read it all, close it. There's some magic bytes that need to be said. These are consistent in all samples. This is actually not a very large amount of test cases. Well, I had all just malware samples that were the right malware samples, so this would probably need to be lengthened, and a few other things that you could probably grab from Yara rules. But this became a regex, found it, found the location, and began from there. I knew it was 4 on, so I worked a little bit behind that. So it really comes on to identifying from the actual sample itself, but trying to find the right location of where these hexadecimal parts are. Now, some of the hex pool was actually, they're all got the same hex pool. In the what I'm saying here is the same values that are located in the same binaries. So think of it as a very long key that we sort of grab different bits of. The reason why I hesitate to say key is it's basically a load of different bytes that we just grab random bits from the index values that we get from here. So it's really all dependent on a certain part that's added back. So we need to find the values. The hex pool stays the same. Every sample has a different way of getting these indexes, which lead to the final results that are appended. But anyway, I'm confusing probably a lot of people by saying that. And of course, they're being appended as previously said. I feel like I've talked about that quite a lot. But yeah, this is the final result. I have horrifically labeled that, but we've got, the reason why I've got this up here is this is the unique bytes that would be in the sample that you would identify, and I've got a load of different. The reason why these are censored is because really I need to censor the samples, but these are the configs for them. You can see some slight IPs and then some of the hashes that are there, but some of these are password groups and the IPs that are being used. Yeah, really important that was successful. But yeah, note that the malware family is not important. It's all about understanding the core concepts and then moving on with that. Cool. Thank you very much for watching, guys. And if you want more content, please down below tell me what you want. I'm going to work on Ghidra. If you want Ghidra, then give me a snake emoji or call me a snake or something. I don't know. But yeah, I'll be working on a lot more content, open to requests.